Okay, now it's time for the fun part. Who's got some questions here for our panelists?
Yeah, I've got lots of questions. Jan, first of all, when I started looking at the utilities and I got the ballistic reaction that you found,
Yeah.
the ballistic reaction is tied into their business model and what the PUC will allow them to do. And like you found, the first thing is you can't sell power because only the monopolized utility can sell power as allowed by the PUC.
Yep.
So you have to come up with a completely different business model. But in that business model, there's another loophole you can take advantage of. That if you have those vehicles on a two-way charger in that garage, you can provide a service to the utility for purposes of regulation. And they have to pay you. So that kind of turns the whole market around. And for a question to you, I guess, have you looked at any of the PUC implications of that building, not just on the consumption side?
We basically dealt with the utility trying to get costs from what they would have to do to just supply the power. But I'm going to turn this over to my friend Tony because he, pardon me, Tom, but he has actually looked at that V2G stuff more than we have probably. Is that true?
That is true. We have looked at it. There are several places where V2G will create value, but we have to be very specific in identifying those and not getting excited that we're always going to be doing this service, because any cycle on a battery is a cycle of degradation. So every time you charge and discharge the battery, it's one cycle of life, okay? And auto manufacturers are designing the vehicles to deliver enough cycles to get you through the life of your vehicle. They're not designing it to necessarily have extra cycles for V2G. Everybody's driving profiles are very different. So some may have the opportunity to do that, some may not. V2G does have value in its ability to offset building costs. I think the system needs to be, you need to draw the system boundaries. Who are you interfacing with? Are you interfacing with your utility at your home? Are you interfacing with your utility through a commercial business entity? Are you interfacing with your employer, your business? Because they have an electricity bill too. So those interface boundaries are going to have to be drawn before we can really answer the question about how much value can we achieve from it.
Okay, another couple of questions with respect to that. When we looked at battery life and life cycles, it's highly nonlinear with respect to the position and the state of the charge and the percentage of state of charge that you do a cycle. And it looks like to me that if you're looking at the 5 or 10% variation in state of charge that these regulation services require, it's trivial in terms of degrading the battery life. Have you found anything like that, or did you look at that?
I think in general that answer's correct. However, battery life is not only a function of, if you look at those cycles, depth of cycle versus number of cycles, you end up almost coming out to energy throughput being fairly consistent across the degradation period. So yes, you could do lots and lots of small cycles, 5%, 10% cycles on your battery, which is why hybrid vehicles have been very successful, is because that's how we operate the batteries. However, that's also only 1 hour a day. If you're going to keep this car connected to the grid and provide regulation service by simply adjusting your cycles up and down 5 or 10% for the other 23 hours of the day, that's a lot of energy throughput relative to your driving throughput. The other flip side of that is you may not need to do it every hour of the day. And the other part is you can do a lot of that same service by simply regulating the charge feature. You don't have to charge at full rate all the time. You could charge at half the rate and be able to move up and down in your charge rate to accomplish the exact same functionality.
And the utility has to pay you.
And the utility, yes, if you're in the right utility district, you could potentially have that feature. Utilities don't normally want to deal with 3 kilowatt loads, though. They want to deal with megawatt loads.
Well, if you had that whole garage, now you're starting to get to the megawatt loads.
Now we're getting much closer when you start about aggregating vehicles together in a parking facility or a city.
Tom, let me jump in for 1 second. There's a really interesting study about what Tony's talking about, having to do with the fundamental difference between nickel metal hydride and lithium batteries. And with lithium batteries, it's the energy throughput that matters. With nickel metal hydride that you've heard about, it's the number of cycles that matters when you look at lifetime, if you keep it within a state of charge range. So I just point this out, the literature's out there, but the two kinds of batteries are totally different as far as lifetime goes.
Thank you. Yeah, I'm aware of quite a bit of that. Tony, the other thing, I'd really like to congratulate that study on the accessories, because I've done a similar study on internal combustion engine vehicles, heavy-duty vehicles in particular, and if you can take the accessory loads off the engine, which is extremely inefficient in most cases, you can get similar savings in the rest of the internal combustion engine fleet, which is also pretty phenomenal. So you might want to extend your study into that, not just the electric vehicles.
Well, it would be wonderful to see the hybrid industry be able to transfer technology back into the conventional vehicle market, in that we have technology in these hybrid vehicles for travel, improving our driving behaviors, and potentially components like electrified air conditioning systems. Those systems transferred back over into conventional vehicle technology, we'd have additional savings in our conventional fleet that could get introduced at a much more rapid pace.
How about back here?
Monica Trousey with E&E. Jan, you mentioned that you're not worried about the rare earths issue, and it's something that's gaining steam in Washington right now. So I'm wondering if you can just explain.
The concern is gaining steam?
In Washington right now.
Yeah.
Can you explain that a bit, why it's not a long-term concern for you?
I'm good at handing these questions off, but I have to say that Linda has 10 times more knowledge about rare earths than I do.
So first of all, they're called rare earths because of the concentration of the element within the ore that it's mined from. But it is actually very common in the Earth's crust. So there are many sources of places that you can go to mine rare earth metals. For example, we used to mine them in the United States and California up until I think about 10 years ago. And so the real issue right now is how soon can other mines be brought up in order to bring competition. That takes a certain amount of time. Australia is bringing up mines. They're relooking at opening the mines in California. And so it's not a scarcity issue. It's really a question of time and policy. So it can be overcome, but it is a real concern. Right now there is a bias towards China production. And so I mean, I'm not an expert on what policy is, but we know that Washington is working through that.
If I can add just something also, Mary, right back here, to that question. On the Toyota side, we are doing R&D all the time on next generation hybrids and electric vehicles. And we, as part of that ongoing process, of course, you're always looking to improve the product and make it cheaper and using materials that are less rare. So for example, about 3 months ago or so, there was some discussion at the Detroit show that we are looking very seriously at induction motors over fixed magnet motors, and the fact that those do not use nearly as many rare earth materials makes a big difference, and we will be going online with that type of motor in the future. And of course also looking at other high valence battery types and solid states that again would hopefully improve the product and make it more affordable. So as a natural part of R&D of improving the product and finding a cheaper way of doing it, we're finding paths around the rare earth issue.
Go ahead, Dennis.
Okay, having brought up the matter of battery degradation, how about the matter of battery degradation in response to level 3 charging?
Level 3 charging is something that came up in our sub-team as an idea to kind of match the filling station paradigm. But battery chemistry has a long way to go before you can jam 200 kW into that battery for a 5, 10, 15-minute charging period. So that's a major concern, and I haven't heard the solution to it. I don't think we can do it now, but down the road it's possible.
I'll just comment on that real quick. The work that's going on in the DOE EV project, there are fast chargers that will be installed along with the Nissan Leaf vehicles that are being rolled out. So there will be some experience over the next couple of years. Also within the laboratory system, we'll have fast charge equipment available to go with our vehicle fleet, and obviously there'll be a lot of interest in that. Yeah, it's going to generate heat. You try to push that much power in for a period of time, you're going to generate heat. So that probably degrades the system, but remember, if you've got a thermal management system, it's only a short period of time, and it's time at temperature. So if you're not there very long, then it probably isn't a big deal.
And is heat the main mechanism of degradation, or is it chemical activity independent of heat?
Because you've increased the heat, you've increased the kinetic reaction rates, and therefore you're more active and degrading faster.
Let me add one sentence, Dennis. When we talk about quick charging, the standard that I pointed out, the SAE standard, allows you to do up to 200 kW, but people are thinking more like 50 right now. 200 is kind of the upper level limit of that so-called level 3 criterion.
I guess the other thing I was going to add, Dennis, is I think as part of the DOE program, I think here in San Diego, the plan for the fast charging part of their map is about 40 fast chargers on the interior of the city of San Diego, I think last time I looked at the map. So yeah, they're planning quite a few of the fast chargers right here that we'll be able to study and see the data from as NREL gets that data coming through.